And picking up at number 13, where we left off, it says the Richter scale magnitude R of an earthquake is based on the features of the associated seismic wave and is measured by R is equal to log of A over T plus B, where A is the amplitude in micrometers, T is the period in seconds, and B accounts for the weakening of the seismic wave due to the distance from the epicenter. Compute the earthquake magnitude R when A equals 320. So I have R is equal to log of 320 divided by T is equal to 5 plus B is equal to 3.5 and round to the nearest 10,000th. So this is pretty straightforward. You just substitute your numbers in and evaluate. So I have R is equal to 5.3062 in order to round to the nearest 10,000th, which is the fourth decimal place. For number 15, and for the other ones that I skipped to, number 5 and number 9 and now I'm going to skip number 15. It's only because I don't have a graphing calculator in my hand right this second. But what you do is for each of those, you're going to put those tables into your stat function table and then run a quadratic regression line using your stat features. If you don't know how to do that, then once I get started on the quiz with the Math 2 class that I'm teaching right this second, then have somebody run down to get me and I will walk y'all through how to do those on the calculator. But skipping down to number 17, here we have how long must $4,200 be in a bank at 8% compounded annually to become $10,576.31. So if we're compounding annually, then we're going to use our compounding interest formula. And that was A of T is equal to P times 1 plus R over N to the NT power. And what we're looking for is T. How long does it take for our initial investment of $4,200 compounded at 8%, and we're compounded annually, so that's one time per year, to be $10,576.31. And so once I'm here, I'm going to solve this for T. So this is going to be $10,576.31 divided by 4,200 is equal to 1.08 raised to the power of T. Okay, so this is approximately 2.5. I told you I didn't have a calculator in front of me. So 2.5 is equal to 1.08 raised to the power of T. And so in order to solve this, I have to rewrite it as a logarithm. So this is going to be log base 1.08 of 2.5 is equal to T. And when you put that into your calculator and evaluate it, it's going to give you approximately 12 years. Okay. And for number 19, how long will it take for $6,100 to grow to $7,600 at an interest rate of 12.4% if the interest is compounded quarterly? So in a very similar setup, we are looking for how long does it take for $6,100 times 1 plus, and this time our interest rate is 12.4, so it's 0.124 over, and we're compounded quarterly. So we're going to divide this by 4, and then this is raised to the 4t power. And we are looking for how long does it take for 6,100 to grow to be 7,600. So from here, I would divide both sides by 6,100. So this is going to give me 7,600 divided by 6,100. about 1.25, we'll say. So I have 1.25 is equal to 1, and when I divide this 0.124 by 4, what you end up with is 0.031. So I have 1.031 raised to the 4t power. And again, I have to rewrite it as a logarithm. So this is going to be log of base 1.031 of 1.25 is equal to 4t. And to solve for t, I'm going to divide my log of 1.031 times 1.25 by 4. And when I put that into the calculator and let it do all of the fancy legwork, then it's going to take me approximately 1.8 years. So more than 1.5, but not quite 2 years in order to grow from $6,100 to $7,600. Okay, you need to work on the even problems and get a feel for it. And if you have any questions, run down the hall and come see me. Otherwise, good luck, and you'll have another video again tomorrow.